Hello everyone, my name is Krishan Himesha Beratna. I'm a cloud system engineer at CQ Smart Systems. Today, I'm going to deeply demonstrate about the smart home system developed by our team to remotely monitor the temperature of your home using IoT sensor data. To create this cloud-based smart application, we have used Azure IoT Hub, Azure Kubernetes Service, and Azure Container Registry. We have created a link for our Node-RED application in our report. You can access the Node-RED application using this link, and you can access the dashboard using the other link in the report. This is the Node-RED application, and then you can access the dashboard using the other link. To implement the smart home system, first we create a container registry using Microsoft Azure. A container registry allows us to package our applications together with the libraries and other dependencies and providing an isolated environment for running our applications. Then we create a Node-RED image and push that to the container registry repository using Docker. Then we create a Kubernetes service with Microsoft Azure and then create a starter application to create the Node-RED service. Once we create the Node-RED service, we get our public IP address, and using the public IP address and the port number, we can access the Node-RED to create our nodes. Then we create the IoT hub using Azure. This hostname will be used for our Azure IoT hub use in Node-RED, and then for the connection string, we use the shared access policies and this connection string as our Azure IoT Hub receiver connection string. And then we add 3 IoT devices to demonstrate our application using Azure. We use these nodes to create our smart home application. First, I have used 3 injector nodes to trigger the temp gen function. In the temp gen function, I have connected in the first one, I have connected the temp sensor 1, which is the IoT device I have created in the Azure IoT Hub, and I connected using the primary key here. And then I generate a random temperature using this function. And then I use this injector node to create a message payload every 40 seconds for the demonstration purpose. Once it triggers, the function node sends the randomly generated temperature data to the Azure IoT Hub. We use different time intervals to trigger the tempgen function for each device. We have attached 3 IoT devices we created in Azure IoT Hub, and it sends the data to the Azure IoT Hub once it triggers. These graphs shows the analytics of the messages sent today. You can monitor the messages, the traffic that comes to the IoT devices using Azure IoT Hub. We use Azure IoT Hub receiver to receive all this data sent to the Azure IoT Hub by the multiple sensors. Azure IoT Hub receives all the data that's sent to the Azure IoT Hub, and using these 3 function nodes, we filter the data that we use to display in our dashboard. Then we use the data processing function node to process all the data received by the Azure IoT Hub receiver. Each data processing function node receives all the data coming from these 3 sensors. From this function node, we filter out all this data coming to the each function node. As an example, the first function node is filtering only the temp1 data coming from the temperature sensor 1. If the message payload can't find the temperature data relevant to temperature 1, which is the temperature sensor 1, it print out temperature data not found. If you carefully look at these debug messages, you can see one payload of temperature and two other that prints out temperature data not found. That's because if this one sensor sends out the data, it receives by all three data processors, and if each processor cannot find the relevant data to its node, it prints out temperature data not found. We are using these nodes to display the temperature outcome of each sensor in the dashboard. We have a gauge, graph, and also we use a debugger to display the messages coming from the data processor, and also we use email function to send the email to the user if their temperature is higher than their desired amount. For each temperature sensor, we use these nodes to display the data in the dashboard. For each sensor, it has the dedicated temperature gauge and a graph that shows its temperature variation. For the demonstration purpose, we have created a single email account and provide the credentials to the email node to send the email if the temperature is higher than the desired amount of the particular area. We have created app password to access these nodes to send an email to the user. In the demonstration purpose, I have used the same email address as the sender and the receiver. So if you see the emails that received from the node, so you can see that the temperature warnings have been sent from all the nodes if the temperature is higher than the desired amount of the user. These are all the functionalities behind our working application. We can use these approaches to build a real smart home application using the cloud services and IoT devices.